Hi, I'm Anna, and this is my Lab 2 Lines of Charge video. For an introduction to this lab, the background was basically the same as last lab, that everyday objects can take on excess negative charges or can lose negative charge and become positively charged. The goal of this lab was to calculate the charge present on a piece of Scotch tape by using a more detailed model for the line charge and comparing this result to the point charge model we used in the last lab. Fundamental physics principles used were Coulomb's law and vector electric field. A summary of the results: the charge on the floating tape Q was determined to be 6.55 times 10 to the negative 9 coulombs by the point charge model and 7.12 to 10 to the negative 9 coulombs on the line charge model. Some key observations from the last lab that also were applicable in this lab were that two U-tapes repel each other. The U-tape is attracted to neutral objects such as a book and a desk. The U-tape is positive since it was attracted to a negatively charged pen, and since the net force in the y direction is 0, since momentum is not changing. And because of this, F grav is equal to F electric, and I showed this also in the free body diagram below. Data taken, which is the same as lab 1. The length of tape I used was 0.175 meters, density of tape was 1 gram per meter, mass of tape is 1.75 times 10 to the negative 4 kilograms, and height of floating tape was 0.015 meters. It's just a picture of the tape I used and the figure taken directly from the lab 1 protocol showing the floating tape procedure. The calculations I did last time with the point charge model, I ended up finding that the charge on B would be 6.55 times 10 to the negative 9 coulombs. Found that the number of electrons on tape B was 4.09 times 10 to the 10 electrons, which was via a deficiency since the tape was observed to be positively charged. Number of atoms on a sticky slice of tape was determined to be 1.75 times 10 to the 9 atoms, and the ratio of deficient electrons to number of atoms was determined to be 23.39. This was all for the point charge model we did last lab. Now for this lab, the code I used is pictured here. Well, the first two pictures of it are. Basically, what I just did with this code is I plugged in the charge I found with the point charge model and slightly altered it by around 0.1 times 10 to the 9 negative 9 each time until I got the outputs of force electric and force gravity to be approximately equal to each other. This is more of the code. So I ended up finding that the charge that would make the magnitude of electric force and the magnitude of gravitational force approximately equal was 7.195 times 10 to the negative 9 coulombs. This made the F electric and F gravity equal to approximately 1.72 times 10 to the negative 3 newtons. This is a picture of my model below showing the arrows of force gravity and force electric and the tape. The assumptions made in this code were to ignore air resistance on a moving object. Each U-tape has approximately the same amount of charge. It's evenly distributed across the length of the tape. Now some questions and conclusions. If we had modeled the tapes as a point charge, the calculated charge would have been the same as that found in lab 1. The differences in the charge calculated between these two models were the point charge model calculated the charge to be 6.55 times 10 to the negative 9 coulombs, whereas the line charge model calculated the charge to be 7.12 times 10 to the negative 9 coulombs. The point charge model versus line charge model, these estimates differ because the point charge model assumed that all the charge was centered in one point on the tape, where the line charge model assumed the charge was evenly distributed throughout the tape. The line charge model is likely to be closer to the actual value because the tape is not a point charge in reality. And that is the end of my presentation.